Okay, going to broadcast the multiple choice section. Remember, there are 75 questions. You get an hour and a half for this section. You want to find your 40 or 50 that you can do. If you can narrow down any of the others, please do so and then guess. And if you cannot narrow it down, leave it blank. The atom with the smallest atomic radius. In the matching at the beginning, you can use the atom answers more than once. Okay, I will accept either B or C for this. This is the element that's farthest to the right on the periodic table are going to be the smallest. Top right, F or any are acceptable. Any being a noble gas sometimes is weird, so some people picked B. Chemical properties similar to that of oxygen. We know that sulfur and oxygen and sulfur are on the same column. They both end in S2P4. They have the same chemical properties. That's going to be S. Okay, so the answer to that is D. The element that forms a basic solution when dropped in water, immediately you should think about alkali metals when dropped in water. Cesium is the only alkali metal present, so that's E. Element with 3 electrons in the p orbital. It needs to be somebody that ends in p3, and we know that that is going to be phosphorus. Same electronic structure as Mg2+. Well, Mg2+ has 12 protons and 12 electrons, and neon has 10 protons and 10 electrons. In order for magnesium to mimic neon, it needs to shed 2 electrons. Mimicking it, it's trying to have a similar electron structure. So the answer is neon. We could use that answer twice, perhaps, depending on what you chose for 1. Second set of matching. Has an average atomic or molecular speed closest to that out of N2. Remember, speed is based on mass. N2 is 28 grams per mole, and CO is also 28 grams per mole, so the answer is D. 1 liter of 1 mole of this gas has the greatest density. We're basically looking for the one with the largest molar mass. We locked the volume at 1 liter. We locked it at 1 mole, so Xe has the largest molar mass there, so this is B. Has the greatest rate of effusion through a pinhole. Again, effusion, diffusion, and speed are all based on molar mass. The smallest one here is neon in terms of molar mass, the lightest actually, and the answer is A. Forms a weakly acidic solution when dissolved in water. So it can only be A or B because they're the only acids. Chloric acid is a strong acid, so the answer is B, acetic acid as a weak acid. We know in solution, copper chloride is blue, so the answer to this is C. And a white ionic compound is very soluble in water. Here's the trick. We know that alkali metals are very soluble in water. Very, always. D is the only one that's an alkali metal. If this threw you off, just think about sodium chloride. It's white. It's a white ionic compound. They're not talking about a precipitate here. They're just telling you the color of the solid before it gets put in water. An oxidation reduction reaction, I actually would accept A or B here because oxygen does go from 0 to -2. Carbon's charge does change as well. But the true oxidation reduction reaction is B, 0 to plus and 2 plus to 0. We have a change in charge. So B is the best answer. Precipitation reactions form precipitates, things that are not aqueous in water. There it is, the solid. So that's C. Moving on. Okay, part B, going on to the standard multiple choice questions here. Which of the following rate expressions agrees best with the mechanism? In this mechanism, you want to focus on the slow step, and you want to focus on the reactants of the slow step. Only them can be reflected in the rate law. N2, O2, O2. They have to be there. NO, that's in the fast step. It can't be that. NO and O2. It has O2, but it has NO. That's in the fast step. Does not affect the rate. N2O2 and N2, nothing else. They're being multiplied by one another. Therefore, the answer is going to be C. NO is in the fast step. NO2 is in the fast step. Slow step is what matters. So what this really would look like is you would have 2 hills in this reaction. That first EA would be the slow step. That affects the rate of the reaction. In which of the following species does sulfur have the same oxidation number as it does in H2SO4? So in H2SO4 we have 2 for the H's plus X for the O's minus 8 equals 0. We know that it's 6. Well, H2SO3 is different than H2SO4, so it can't be that. The answer is actually going to be E as you go through it. However, we know it's not this because it's -2 there, obviously, and we know it's 0 there. So it's really between S2O3 and SO2CO3. For B, that's going to be 2x minus 6 equals -2. So 2x in this case is going to be equal to 4, and there x is 2, so we know it's not B. Let me show you why E is right. X minus 4 minus 1 for the CLs equals 0. We know x would have to be 6 in that case. At 25 degrees Celsius, aqueous solutions have a pH of 8. They have a hydroxide concentration of what? Now, we know that pH plus the pOH equals 14. This is going to be our route to the OH concentration. So the pOH must be equal to 6. And if 6 equals the negative log of the OH minus, then 10 to the minus 6 equals the OH minus concentration. Just taking the anti-log, there's the answer right there. When solid magnesium is added to a solution of hydrochloric acid, the surrounding temperature immediately increases. Okay, T goes up in the surroundings. Delta H is less than 0 because heat is released to the surroundings. Delta H is less than 0, so we can get rid of C as a choice. Hydrogen gas is produced. Okay, usually in these problems, if you did not draw it out, a gas would tell us that it's getting messy. Delta S is less than 0. However, if you did this problem out, you might have seen that delta S is less than 0 because you go from 3 moles to 2 moles. So in this case, I messed up by giving you a reaction you could draw. If you chose delta S being greater than 0, okay, let's go through and get delta G first, and I'll tell you what we're going to do. Delta G, without doing God, I hate this stuff, delta G you can get because it said it immediately increases when you mix them. It happened on its own. So delta G is going to have to be less than 0 because it's spontaneous, getting rid of this and getting rid of this. I accepted both of these answers for 17 due to the discrepancy with delta S. With problem 18, I see K. Without even looking at anything, I'm going to set up an ice chart. It's a KSP problem, therefore we have to be starting with a solid, and we know that solids don't count in the equilibrium. They do break up into their ions, plus 2OH minus, don't forget that too. We're going to go through this, and they would like us to calculate KSP. Well, initially, we know that these are 0. We know it's going to shift to the right, so we're going to have X and 2X. So X plus X plus X, 2X. We're going to plug that in to KSP. I'm going to go down here a little bit. So we know that KSP is going to be equal to Zn to the first power and OH to the second power, which is going to be equal to X multiplied by 2X squared 4X cubed. So if we find X, we're home free. Well, they told us that the OH concentration, the saturated OH concentration, is 2 times 10 to the negative 6. Well, that means that 2X, because that's OH, is equal to 2 times 10 to the negative 6. That means that X is going to be equal to 2 times 10 to the negative 6 divided by 2. If you plug that back into this expression, we are going to end up with a practice that until you get that answer correct. Continue the last 6 problems on the next podcast. Take care, everybody.